Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I am going to discuss about the problem-solving question discussion on real-world problem representation in Fuzzy set. This is the course outcome for this Fuzzy Logic module. It is the third module on the course Applied Artificial Intelligence. After the completion of this course, students can examine the situations that are inherently fuzzy while designing the logical systems to deal with ambiguous data. Now, here 2, 3, 4 questions I will discuss related to the fuzzy set. Now, let me discuss what is the meaning of fuzzy set, why it is required in artificial intelligence. Already, I have discussed in my previous video the theoretical concept about fuzzy set, why it is required. Once again, let me repeat here. Actually, fuzzy logic is not a logic like a Boolean logic. It is a concept which is used in artificial intelligence to handle uncertain situations where the information is vague or imprecise or unpredictable. So in that situation, this fuzzy logic can be applied, and to handle this fuzzy logic, we take the help of fuzzy sets. Fuzzy set is also not like our normal set theory. It is bit different here. Same operations are performed like union, intersection and difference operation, but little bit difference is there. Now let me discuss the first question based on this fuzzy set. Let us consider age to be represented using fuzzy set. We will be using two fuzzy sets. One is young, another one is very young, to represent different age ranges. Explain how the membership value is affected by two different functions. So here the question says that we have to consider two fuzzy sets or two functions. One is young, another one is for very young. And how this membership value is affected by these two different functions. Now, what is the meaning of membership values? Actually, in fuzzy set or in fuzzy logic, the value ranges between 0 to 1. Means it may be 0 or it may be 0.1 or it may be 0.2 up to 0.9, and the max value is 1. So here it is not fixed like Boolean logic, like if the statement is true, we used to consider it is 1. If the statement is false, we used to consider as 0 in case of the crisp logic. This is our crisp set or is called as crisp logic, but this is our fuzzy set or fuzzy logic. In fuzzy logic, as fuzzy logic supports partial membership, that means the value it ranges between 0 and 1, whereas crisp logic or Boolean logic supports only two values, that is 0 or 1. Either it is absolutely true or it is absolutely false. Now that this membership value, how it is affected for these two sets, that we will discuss with the help of the graph. Now, okay, so here we are considering two sets. One is the young set, another one is very young set. Let us consider the set A is the young set and B set is considered as the very young set. A is young and B is very young. And the young set belongs to the age between 0 to 90, and very young set it belongs to the age 0 to 60. Now, if the age A belongs to 0 to 90 and if the B set belongs to 0 to 60, then how the membership value we can assign if a person is like at the 30 years of age, what membership value we can assign? That from these two assumptions, what we can assign as A set belongs to the young set and whose value ranges between 0 to 90, means the least value is 0, where youngness would be very high, and gradually when we move at the age of 90, youngness will be completely 0. Okay, that means at the age of 0, youngness will be 1. At the age of 90, youngness will be 0. But when we consider the very young age, as it belongs to 0 to 60 years of age, that means at the age of 60, youngness will be very high, and when it reaches the age 60, then youngness will be 0. Now, what will happen if a person is having the age 30 years or 45 years? What would be the membership value? Should we write 0 or 1, or should we write some other values? That we will discuss with the help of the graph. Now, this is the graphical representation for this problem here. Now, you can see this is our x-axis and this is our y-axis actually. The x-axis represents all the CRISP values. CRISP values means all the real numbers. So, 0, 10 up to 90, because we have considered here as per the two functions a and b. One is 0 to 90, another one is 0 to 60. So max age is 90. So that is what all the ages we have considered here in the x-axis: 0, 10, 20, 30, 40, 50 up to 90. And y-axis represents the membership values. Normally the membership values are represented with the symbol mu symbol. If the set is A, we are considering, then its membership value can be represented A tilde symbol. Okay, A tilde symbol within bracket the value of X. That value we will find out, the membership value of that point we can find out. Now, on the x-axis you can observe, here you can see there are two lines are there. This is A bar and another one is B bar. Right? So A bar represents the Fuzzy set for young people, and B bar represents the Fuzzy set for very young people, which ranges between 0 to 60. Now, if you consider this one, this A bar, this symbol, this one A bar, which ranges from 0 to 90. That means starts with the 0 age and ends with the 90 age. So, as I told, y-axis represents the membership value. So you consider first for set A, that means A set belongs to young people. So young people represents 0 to 90 age. So, and when the age is 0, its membership value is considered as 1. So while when the person is, if we move towards 90, slowly 0 years, then 10 years, 20 years, move away from 0, and when the person reaches 90 years of age, the youngness of the person will be vanished, or which is nearly equal to 0 itself, this one, 0. But what happens if the age of the person is 30 years or 40 years or 50 years? That is very important, how we can assign the membership value. Now, as we have understood that at the 0 age, the membership value is 1. At the age of 90, membership value is completely 0. Now, you consider the second one, which represents the very young category and whose age ranges between 0 to 60. That means at the age of 0, membership value is 1. That means the person is fully young. And when as and when the age is increasing and reaches to the year 60 years of age, the membership value is becoming 0 at the 60 years of age. Now you can see 0 to 60 years of, at the age of 0, membership is 1. At the age of 60, membership is 0. Now, if you consider the middle point or middle age between 0 to 60, which is 30 years of age, if you plot this line, almost you will get half. Almost you will get between 1 and 0. This is the middle point and you will get here. That means that this is the membership value when the age of the person is 30. And this membership value is for when the, this is only for the very young people. That means whose age ranges between B value, right? Very young people whose age ranges between 0 to 60. That is equal to 0 to 60 years of age, right? And if you continue this line towards the up next line, which represents the young people, that means set A, almost you will get around the membership value, you will get around 0.9. That means what we have understood, at the 30 years of age, when we are considering the very young people, means B set, the membership value is 0.5. And the same line, if you continue to the set A, then at the 30 years of age, you will get the membership value is 0.9. Similarly, you can find at the age of 40 also, at the age of 50, at the age of 60, gradually the membership value will be decreased. So what we have understood here, two sets we have considered. One is the young set, another one is the very young set. A represents the very young set, B represents the very young set, and their respective membership values on the y-axis. So here the membership value is 0.9 at the 30 years of age for the set A, means for young people, and here we are getting the membership value 0.5 for the B set, that means very young people. This is what we can represent the fudgy values, as it supports the partial membership or the membership function. That is why all the membership value should range between 0 to 1. Now let us consider the second question. Represent the concept real number close to 0 by fudgy set A. That means one fudgy set we have to consider A, which consists of all the real numbers closer to 0. How we can represent with the help of graph. So this is the representation of the real numbers closer to 0. So we can assign some membership function here, as A represents all the real values. That means it may be 0, 1, 2 or -1, -2 like this. So what would be these are the crisp values. Okay, these are the crisp values, and for each crisp values, what would be the membership function in fudgy set. So to define the membership values or the partial membership which lies between 0 to 1, one membership function should be defined. Let us suppose for this A fudgy set. Fudgy set, normally we set representation, normal alphabet we can use. But for fudgy set, we have to write like this, A tilde bar. That is the representation of the fudgy set. Now for fudgy set A tilde bar, we can write the membership function mu of A tilde bar of x. That is equal to 1 by 1 plus x square. This type of membership function, it is to be created by the creator who is trying to create this particular graph. It is every time it is not fixed actually. That depends upon the manufacturer or the creator. So here the membership function for the set is equal to 1 by 1 plus x square. Now you see the graph here. This graph represents all the real numbers on the x-axis. One middle point is 0. Right side, if you move 0, 1, 2, 3. Left side, if you move 0, -1, -2 and -3. And this y-axis represents the membership values. Now what you can, and this is a symmetric distribution we can say. So here, if you consider at the point 0, that means when the value of x is equal to 0, what is the membership value here? The membership value is equal to 1. This is the membership value which is equal to 1 at the when x is equal to 0, means mu of x is equal to 1. Similarly, when suppose we'll consider at the x, means x is equal to 1 at this point. So what will be the membership value? Exactly at the middle. So almost we will get 0.5. So that means mu of x is equal to 0.5. Same thing if you move forward from 1, then 2 and then 3. You can observe here in this graph, at the point 3, when x is equal to 3, mu of x is equal to 0. The membership value is closer to 0, almost equal to 0. Same thing, if you take the value x is equal to 2, then mu of x, it will be like 0.2 or 0.1 something. All the membership values you can find out from this graph, which will lie between 0 to 1. Same thing if you move in the left side direction from 0, that means if x is equal to this -1, same membership value we will get as 0.5. If we take x is equal to -2, we'll get around 0.2. Or if you go to -3, if x is equal to -3, the membership value reaches to 0. How we are calculating here? You just put this formula. As this formula is already given, because as I told, especially the fuzzy logic, it is related to the linguistic variables. So linguistic means if I say the temperature is hot, the temperature is very hot, the temperature is extremely hot. So depending upon the priority of the word, the membership functions are defined. So that is why the membership functions are not constant every time. That is created by the creators or the manufacturer. So for this real number, as the question is given, how to represent the real number which are closer to 0. So this can be represented with the help of symmetric graph or symmetric distribution graph. And here x-axis represents the crisp values and y-axis represents the membership values. And by plotting the graph, you can understand at the point 0, membership value is 1, exactly 1, and closer to 3, membership value becomes 0 for both left and right side. And how we are getting, either you follow the graph or else you can follow this formula, as the formula for the membership function is given for real number 1 by 1 plus x square. Now you can write when x is equal to 0, 1 by 1, it will be 1. So directly we are getting the membership value as 1. If x is equal to 1 means 1 by 2, that is equal to 0.5. Here we are getting. If x is equal to 3, like this you insert the values in place of x and find out their membership values. Now the third question is, represent the concept real number very close to 0 by the Fuzzy set A. The previous example I have shown, I explained how to the representation of the real numbers closer to 0, but this question is related to the representation of the real numbers very close to 0 by the Fuzzy set A. So this is what the representation would be. Very closer to 0 means the distance between 0 and 2, it will be very closer. Definitely the membership value gradually it will be decreased. So that is why the membership function is defined like this. If A is the set, then Fuzzy set would be A tilde bar. So mu of A tilde bar of x for any value of x, the membership value would be 1 by 1 plus x square whole square. Now you see the graph here. 0 is the middle point. X-axis represents the crisp values. 0 is the middle point and right side of 0, 1, 2, 3 is given. Left side 0, minus 1, minus 2, minus 3 is given. When x is equal to 0, insert 0 in this formula, you will get the membership value as 1. If you get like mu of x, like if the membership, if the crisp value is 1, what would be the membership here? Almost here we will get, right? So that is equal to 0.25. If you x is equal to 2, then in that case we are getting the membership value as 0. But at 0 it is 1. Same thing for left side also. Even though it is negative, we will get the same answer. So this is what that means, what we have understood from our previous example and this example. In the previous example, the membership values differs, but all the membership values, one thing you have to remember here, always the membership values lies between 0 to 1. Never it goes beyond 1 or less than 0. That depends upon. Now here the values are very closer to 0 and very closer to 1 because that depends upon the membership function. As the membership denominator of the membership function is squared, that is why the membership values are very closer to each other. That means at the point 0, membership value is 1. At the point 1, when x is equal to 1, the membership value we are getting 0.25. But in the previous example, what we got here, when at the point 1, when x is equal to 1, we are getting membership value as 0.5. But in this example, as it is closer to 0, that is why we are getting 0.25. That indicates that if the real numbers are very closer to 0, then their membership value will drastically, it will be decreased for both the sides, whether it is left side or right side. Now one more example. So the fuzzy and crisp representation for a set of good students having a CGPA of 5.00 and above. That means we have to represent with the help of graph and with the help of mathematical representation for good students who is having CGPA 5 and above. Okay, means the student who is scoring 5 and above, they are considered as good student. If it is less, they are considered as bad student as per the crisp representation. Whereas in case of the fuzzy representation, we cannot say that the student who is scoring only 5.0 or above, they are good student. Then what about the student who is getting 4.9? That also we need to consider whether he or she is a good student or probably a good student. student. That can be done. The thing which is uncertain or it is touching to the true value, that we can assign with the help of fuzzy membership values. Now, this is the representation of the crisp logic for the given question. A student either fully belongs or does not belong to the set good student. There is no partial membership. This thing is very important in crisp logic. There is no partial membership. It considers either 1 or 0. If it belongs, that means it is 1. If it does not belong, it is represented as 0. That means as per the given question, if a student is scoring 5 or above, then it is considered as 1. If a student is less than 5.0, even though it is 4.9, for crisp logic, that is considered as 0 only. So how we can represent mathematically this representation? If we are considering the set A, then A of crisp of x, that is equal to 1 if x is more than is equal to 5.0 and is equal to 0 if x is less than 5.0. Where x is nothing but the CGPA of the student, and this part A of crisp of x is the membership in the crisp set. This membership value only contains two things. One is 1, another one is 0, whether it is belong or does not belong. Now this thing we can represent with the help of graph so that you can understand. Now I'll show you one example here for the crisp representation. Now 3 students are there and their CGPA also given. Unless his CGPA is 5.2, then definitely crisp membership would be considered as 1, means good student. Bob is getting 4.8. 4 point means below 5. That means 0, strictly 0, not a good student. Karen is getting 5, exactly 5. That means the membership value will be 1. That means he is considered as a good student. So what we have understood from this example, the crisp membership values, either it would be 1 if it belongs to the set, or else it would be 0 if it does not belong to the set. That is the clear representation or the logical representation or the crisp representation of this problem. Now you can see this graph, how we can represent. So now if you see the graph here, x-axis represents the crisp values. So if the person is scoring like 0 to 5, means mark is 0 to 5 marks, then its membership value is considered as 0. But above 5 or above, then it is move up, and here we are getting the membership value as 1. Now you can observe this part means the marks between 0 to 5 or less than 5. So membership value is 0. But 5 or more than 5, membership value is 1 here, right? So either 1 or 0. So this is the way the crisp representation we can do with the help of graph. Same thing if we go for fuzzy logic, which allows the partial membership, meaning a student can be a good student to some degree even if their CGPA is slightly below 5.0. So mathematically how we can represent mu of good of x, that is equal to 0 if x is less than is equal to 4. If a student is getting or scoring 4 or less, then it is considered as 0. If a student is scoring 5 or more than 5, it is considered as 1. But what about the student who is scoring between 4 and 5? For that, some membership function should be defined. So this is what the membership function. The function is x minus 4.0 divided by 1.0. If x lies between 4.0 to 5.0. Now here, as I told, if CGPA is 4 or below, then it is considered as not a good student whose membership value would be 0. If the CGPA is 5 or above, then the student is considered as a good student, so whose membership value will be 1. If the CGPA is between 4 to 5, then the partial membership would be there, and whose value will lies between 0 to 1. Not exactly 0, not exactly 1, in between 0 to 1. That is why fuzzy logic supports the partial membership. So to handle that partial membership, we should aware about this membership function. Now we'll see the example for this fuzzy logic for this student example. Now 5 students and their CGPA are given. For the first student, alias the CGPA is 5.2. Definitely the fuzzy membership value would be 1.0, means fully good. Then for next student, CGPA is 4.8. As I told, if it is less than 5 and more than 4 marks, CGPA is more than 4, less than 5, then we have to apply this function x minus 4.0 divided by 1.0. So in place of x, you apply the value what CGPA the student is scoring, 4.8, we will get almost 4.8. So we can assign the linguistic variable here mostly good. Not exactly fully good, mostly good. Now for the third student, Carol, whose CGPA is 5.0. So no need to think, even if you apply this 5.0 in this formula also, 5.0 minus 4.0 divided by 1.0, then we will get the value as 1. So that is why here also we are getting the membership value as 1, which is in linguistic format we can tell that fully good. Okay, here also fully good, here mostly good. And for the fourth student, Dave, whose CGPA is 4.5, again it lies between 4 to 5, so we can apply that membership function x minus 4.0 divided by 1.0. So in place of x, if you write 4.5 minus 4.0 divided by 1.0, you will get 0.5. So this is the membership value for the student Dave, who is considered as moderately good. So these are, and for the last student whose CGPA is 3.9, less than 4. So as for the formula what we have defined, if any student score less than 4, then the membership value will be considered as 0. This one. So same thing. So that comes under that formula. So here the membership value would be 0, which is considered as not good. And here you might be observing here what are the values are given in the FOGI membership. So the maximum value is 1.0 and the minimum value is 0.0, and all values lies between 0 and 1. So that is why it is the FOGI logic supports the partial membership whose values ranges between 0 to 1. And all these values can be represented with the help of words of the language which can support natural language processing. So those are called as FOGI hedges in technical term in artificial intelligence. That is why if a person whose membership value is 1.0, then it is fully good. Here also fully good, mostly good, moderately good, and not good. Sometimes what happens, these linguistic variables would be given. We have to find out the membership value. So in that case also we have to apply the membership function depending upon their priority. Priority means fully good, which one to which word we have to give maximum priority. So depending upon the priority, function will be defined. Now graphically we can represent a person if it is as per the membership function. Based on this, if a student is scoring less than 4, it is considered as 0. If the student is considering 5 or more than 5, it is 1. If a student is scoring between 4 and 5, then we have to apply this membership function. So based on this membership function, we have plotted the graph. So x-axis represents all the crisp values and y-axis represents the membership value, which is denoted as mu symbol. Now you can see if the student is scoring between 0 to 4, here the membership value would be 0 only. If the student is scoring between 4 and exactly at the 5, if you see at this point, if a student is scoring 5 or more, here you are getting the membership value almost is equal to 1 here. Okay, this is the 5. And if a student is scoring the value between 4 and 5, the membership value lies between 1 to 0. That means here you can plot the perpendicular line to this line. You can plot this line. Suppose 4.1, somebody is getting 4.2, then 4.3, 4.4, 4.5, like this. So we will get almost the values between 0 to 1. So like this we can find the corresponding membership values, which is represented as mu. Now one of the example it is given, if a student is getting 4.5 exactly, the membership value would be 0.5. Similarly, we can get all other membership values if the scoring lies between 4 to 5. So this is all about for this particular video. And for the preparation of this video, I have referred this Soros Kosik book for artificial intelligence and the website which is given on the screen, codecrocs.com. That also you can follow it. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.